Well, hi everyone. My name's Michael McEwan. I'm head of subject for academic and digital development. I've not met all of you before, but I have obviously met a couple of you for a variety of reasons. I want to chat today about comparative approaches to scholarship, basically comparative approaches to educational inquiry. Just to try and set down a couple of different ways that you can view comparative approaches to research in this area. There's obviously only a handful of us on the call today, so there's no problem at all interrupting, asking some questions, try and redirecting it in a different way if that's what you need. I think that's probably most useful given that there's only a few of us here today. So yeah, what I really want to kind of start off with is by really taking the idea of a comparative study, which now that I understand most of you are in the sciences, I think it would be fair to say you'd probably be in the position of thinking an experiment is a comparative study. And that kind of scientific method of an experiment whereby everything's quite well controlled and all this kind of stuff. But actually, trying to split that up into two kind of competing different inquiry designs, really, where experiment is one arm of that and something else is a different arm. In order just to kind of position this session in the overall scholarship strand of Sarah's CPD session, I've mentioned in some of the other sessions that I've taught this book called Scholarship Assessed. And within this book, there's a very simple framework for building a SOTL inquiry, a scholarship inquiry. And that framework's on the left-hand side here. And it starts off with kind of 6 statements, which any well-evaluated SOTL study should have. It should have clear goals. It's a bit like a research question, I suppose. It should have adequate preparation, which in this context refers to your background knowledge and the foundation for any project or any inquiry. What do you know about the area? What's already known about the area? What isn't known about the area? What literature have you read and what tools are you using and things like this. Next on this list, on this framework, is appropriate methods. And really that's where we're hitting today. What are appropriate methods? Many of you might have heard Sarah and I chatting just before the call started there, kind of chatting informally about something called epistemology, and also a new journal edition that's coming out soon from the Open SOTL journal. And I think Sarah and I both have something going into that publication. And actually it's quite relevant here today. My piece that's going into this is about the importance of preparation and how you should make sure that your subject-based norms don't drive your methods choice, but rather your question drives your methods choice. And my experience in supporting SOTL over the years has shown that the scientists amongst us tend to err towards comparative studies and experiments, even if the question doesn't quite really need that. So I just want to highlight, make sure you always come back to your goals and your question and look at it that way, and try and forget about methods for a wee bit. But if you are led down the route of an inquiry where some kind of comparison is relevant, then there's a couple of ways to go about it. So a couple of questions to ask about those appropriate methods. Is it a comparative question that you've got? Why do you want to compare something anyway? How are you comparing these things? These are little questions to ask yourself to try and make sure that you are in the most appropriate kind of method zone. Of those of you on the call, do either of you have a study in mind at the moment that you're working towards or that you're thinking about?
Yes, I am. So the project that I submitted for the PGCAP, my SOTL project, I did some changes to it, and I'm thinking about submitting to the ethics committee and try to to put it in practice. I was actually working on it yesterday and today. So yeah, I'm hopefully going to get that going soon.
So just for the sake of maybe working with that a little bit, Raphael, can you remind me, that's where my memory's not so good anymore. I will have read this piece, obviously, but I can't quite remember. Can you remind me roughly what your kind of overall question, your overall goal is?
So the pharmacologists or the nursing students that I teach they have always been taught pharmacology in a very specific way, which is just by normal traditional lectures, and they only had 4 sessions every year, and pharmacology was not included in the exams. Everything changed now, so we have double the amount of sessions, and I want to introduce more clinical case studies, problem-based learning. So instead of just talking about diabetes and drugs to treat diabetes, I want to come up with clinical cases and discuss with the students. And I want to compare that with the traditional way of teaching.
Okay.
So yeah, so I will just use the same cohort of students and teach half of the lectures using one method, half of them using...
So we'll come to that. It's the fact that you've got the 2 different approaches then, and you've got this comparison. So actually that fits with this session in the sense of the way that you've kind of framed the question. Obviously, what's important here is you could frame that question entirely differently and look for entirely different things, but actually you've framed it in a comparative way. So it does sound appropriate here. Stevie, what about yourself?
Yeah, so I have only actually been at Glasgow since the end of last year. But one of the projects that I'm hoping to do is just, there's a couple, some of them are more fun than others, but the first one is looking at induction, student induction, and the sort of particularly in level 1. So the idea at the moment would be to create materials that other schools have been using. So that's the sort of premise for that. And they've been successful in other areas, and then gather feedback from the incoming level 1 cohort. So there's not really a huge comparison there, because they either, there's not a control group that gets one way and then the other way. But it's more just a sort of analyzing feedback, seeing what works, what doesn't, and then keep it in continuous development. So that's probably the most developed project I have on the go.
Yeah, okay, that's good. As you say, it doesn't sound quite so comparative, but I'm interested to know again, and I'm not picking things up out here, but I'm just pointing out associations that I spot from years doing this job. As a scientist, you mentioned comparison and you immediately went to control group, and one group gets 1 and the other group doesn't. And that's kind of your default position. As I was a scientist for a long time as well. It's a default position as a scientist to say, right, that's my control group, this is my treatment. But it's, as you'll see in a lot of scholarship projects, that approach is not necessarily possible or ethical or even sometimes even useful. So that's maybe one of the things that we'll chat about today. So actually there might be some comparisons within your study. It might fit because you might start looking at the questions differently, maybe not, but certainly maybe thinking about this idea of the ideal experiment not necessarily being possible here. Okay. That's kind of what I want to do. So yeah, in terms of comparative research, I think one thing to look at is often more quantitative. It often is obviously trying to attribute causation between certain factors, or association between certain factors, or the extent of differences that exist. So ultimately the goals are going to be discussing something like, how much better is one group than another, how much more is one thing than another, how different is one thing in another, or questions that are more along the lines of, why are these differences here, what factors are causing these differences or are associated with these differences. That's where all the comparisons come in. And obviously within those two broad goals, you can see slightly different language. There's slightly different outcomes because one will tend towards the significance of differences, the statistical significance of any differences. And the other one will tend to provide outcomes more associated with association and causation as well. So kind of looking at factors rather than extent of factors. But often in scholarship projects, like the rain's just gone on mad here. Often in scholarship projects like the ones you've just described, you'll notice that there are something different going on or something different being put in place and it's being perceived or experienced differently. And then you start to wonder why. And this is where the idea of ex post facto research, after the fact research, and after the fact experiment, so to speak, might come into play here. In terms of the scientist inside you, the treatment has already been unwittingly implemented without considering control and groups and samples. And then you maybe, because of experience, are realizing that some differences are going on here. And that's when you start wondering why. So you're designing kind of an experiment in reverse to try and explore this situation. And often that's what happens in studies like scholarship studies, because you've not necessarily got all those elements of control. So it's kind of like doing an experiment backwards in a way. So instead of taking groups and subjecting each group to different treatments, you already begin with groups that already differ in some way. You've not necessarily laid down a treatment that you have full control over, but you can start looking at all the different factors that associate with those groups that brought about those differences in the first place. So it's kind of things in backwards. I've got a very straightforward little kind of life example that can maybe help illuminate this idea of after the fact research. It might be that you've picked up over the past 10 years in your job or whatever, that students who spend half their life in front of the telly don't get as good grades, and you wonder why. And there could be lots of reasons. Now, it's a very simple little hypothesis here almost. But if you think about trying to design an experiment around this, so again, going back into that scientist zone, the ideal experiment here would be to take your big group of students and subject them to certain conditions that are controlled. So that would, that would be like, okay, group A, you're going to watch tons of telly, and group B, I'm taking it away from you, you're getting none. And then you kind of let the world pan out over the course of a month or two. Lots of things are in place to make sure these things are happening. Then the exams come about, then your students get their grades and their outcomes. And at that point, you can attribute, the difference in grades in an ideal sense to the difference in the television kind of treatment that you've got there. But actually, when you explore what's going on here, you can't really ethically justify that. Well, you can't ethically justify that. It's not even I don't think that's even a discussion to have. It's also probably not possible to implement that, because you can't stop people from, you can't ethically stop people from going somewhere else to watch telly. You've taken it out of the room, but you can just go to someone else's room. You can't control the behavior in that way. It's too messy, it's too muddy, it's too ethically challenging. And obviously this is a silly life example around, taking someone's TV away. But if you can start to put this into your classroom, you can see that maybe by restricting certain opportunities for students, it's maybe not ethical, it's maybe not possible, it's maybe not fair. So that situation of creating that perfect experiment might not be possible in your classroom, in your teaching practice. So that's where this idea of ex post facto research is maybe more appropriate. You kind of eliminate, losing that control in some way. You could instead ditch the idea of control, but still work on measurement and say, okay, we'll in some way measure people's TV watching habits. Perhaps that could be through self-reporting, and therein lies a bias in your outcome straight away because people might not report accurately. And also you could measure their performance on the course. And this is now into the idea of putting a bit of faith into your hypothesis that TV and performance are related, because actually, unpicking this example, there's lots of other things that could be causing a relationship here between something and performance. There could even be things causing a relationship between TV and performance, but it's not the kind of obvious relationship that we've got. So all you can do here is really build up an understanding of association between the factors. You can't build up a causal relationship here, but you can build up an association. So for example, it could be that TV watching and performance on your courses are related. It could be flipped, almost like the statement being the other way around. It could be that performance on your courses and TV watching are related. So it could be, you know, let's think about it in two ways. If I watch too much TV, I don't have time to study, so I don't do well. Or I'm not doing well on your course, so I don't want to study, so I'm filling my time with something else. It's confounding in that way. We don't know which direction the association is, but we just know that there's an association. And equally, it could be some other factor, something else outside all of this, some kind of lurking variable causing a kind of an apparent association between these two. And that's where, Stevie, in your case, the control, that word control would come in, because obviously you'd eliminate that lurking variable, but we can't do that in this case. As a result, it's a much more explorative study. So even though you've got this kind of almost quasi-experimental approach, it's still very exploratory as a study rather than explanatory, which is the typical mindset in an experiment, I suppose. Could ask a slightly different question. So if I flick back, what's the relationship between the two factors? To what extent is one a factor over the other? So this is where you start asking slightly different questions, but essentially around the same thing. And as soon as you start asking things like to what extent, you have to start thinking about criteria that make something large or small, good or bad, you know, on a very simple level, measurement criteria now rather than qualitative criteria. So slightly different question here as to what extent is TV watching a factor on good performance. So straight away, I have to define what's good and what's not good. Equally, you could then define within that what's a lot of TV and what's not a lot of TV, and you've got two-way variables at that point. And then so this starts to turn into a different analysis as well. But you do have a slightly different quasi-experiment here, ex post facto design, where you've got two groups. So that might feel more natural for you as an experimenter. You've got those obvious two groups, and you can start to maybe explain things a little bit more, but you still have to step back and say, hang on, I don't have any control here. I don't know what variables that I'm not measuring are at play. So that's where you have to say, there are potential biases in this. You maybe heard Sarah and I chat about epistemology at the start of this this discussion, and the idea of the kind of scientific method is a very, Sarah, you can correct me if I get this a little bit wrong here, but it's a very positivist epistemology. It essentially a scientist, if they design an experiment perfectly, has put all faith into their experimental design. And if I change X and that causes changes in Y, then the only thing that is causing those changes in Y is X. It's a very positivist mindset. Actually, when you step back and look at experimental design, there are always potential lurking variables in there, and you can start to question how valid is an experiment, and that's a bit more realistic. And the philosophers amongst us might start calling that post-positivist, where you can start acknowledging some of the potential biases in here, that you don't have full control over your experiment. Wind this back several steps, and you're at this study that you've got here, where you actually have effectively lost almost all control. But it doesn't mean that your study's not valid. And I think that's the important thing. You can design a comparative study, and as long as you write down and say, I have no control, there may be other factors at play here. What I'm looking at is an association between A and B. I can't design the perfect experiment. This is what I found. That's still something important. That's still findings, that's still outcomes. And that's what you'll see a lot of scholars doing. They write down their position on how they know what they know. And most importantly, they write down their position on how they might not know certain things from this design. The advantages of that kind of approach, well, the advantages lie in the fact that a genuine experiment involving humans in this kind of social setting like education is really difficult to design, it's really difficult to explore, and it's really difficult to ethically justify, particularly on the scale of your classes and your courses that you teach on, and particularly in where student outcomes are at play. So let's think about Raphael's example of nursing students. You could take your group of nurses and teach them using a method A, and take take half of your nurses and teach them using a method that you suspect is more effective and better, and therefore will result in better outcomes. And actually what you're doing there is effectively unfairly potentially advantaging one group over another. And if student outcomes are at play here, for example, let's say they need to pass your course to qualify and register as a nurse, then actually you're kind of playing lottery with student careers. So, I mean, that's a big example. That's kind of inflating the impact of a lot of these things here, just to highlight a point. But experimental design in that kind of purest sense is not always possible. Therefore, stepping back and doing this kind of after the fact research is maybe much more pragmatic and maybe much more possible. It's also very valuable as an exploratory tool. Your classes change every year, your courses change every year, your students change every year. You don't actually have that perfect ideal experimental laboratory because so much is changing every year anyway. You possibly don't even have a very large number of students in order to make them statistically relevant as well. So actually, a more exploratory comparison is maybe more sensible for your classes than an explanatory one where you're relying on things like p-values ultimately and statistical significance. You know, it's a different beast, that experiment, that design. But it's very pragmatic, it's very valuable as an exploratory tool. It can be a source of future hypotheses. This is something maybe, Raphael, it was maybe quoted in your feedback on that thing you submitted. You know, run it, I might maybe said run it as a pilot and see what you see. Quite often say that in feedback to people. I don't know if you remember what was said.
Well, I did some changes to the project. I don't exactly remember now what the feedback was. But on that point that you were, you know, my issue is really getting rid of this mindset of needing to do a statistical analysis and like losing statistical power. If I teach the same group of students two different methods, then I have less lectures for each method to compare with.
Yeah.
And I see many, I was reading studies and a lot of them use a lot of statistics. And I was thinking about what statistical method I would employ in my study, which started stressing me because I'm like, I don't know, like I don't know if this is powerful enough to be statistically significant, but as you said, as an exploratory tool, that's quite useful still.
Yeah.
So could I, for example, if I write a project, do I need to have like one part of my project exploring statistical analysis, or can I just say that the analysis will be exploratory? There will be a comparison between, you know, the scores of the student, because I'm going to do pre-course quizzes and post-course quizzes, and do like check their learning gains.
Yeah.
Can I just abstain from doing a statistical analysis, or do it?
So it's difficult without knowing what all your data you're collecting is to answer that question. But what I would say, by means of an example, I did I recently completed a project, ironically, with 3 statisticians, looking at their students on 3 courses, and a phenomenon called statistics anxiety, like just the idea of kind of, you know, having to deal with statistics actually acts as a mind block, and it disengages people and things like this, potentially, particularly students. So we were looking at this, ironically, that you say, and because I was working with statisticians, they were very, very, you can understand, I hope, very much in the mindset of statistical significance, quantitative measurements. Let's get everything together. We had hundreds of students on the study because we went across several courses, and we found one significant factor out of the 15 or 16 factors that they were looking for, because it just wasn't powerful enough. You know, there was quite a significant, wrong word, quite a large study in terms of number of participants in a scholarship project, a couple of hundred. Nowhere near the statistical power needed in order to show the significance between, you know, the small variations in the factors are significant. So we had to really rewrite what we were looking for, and that's why they asked me to come in and look at things differently. And we looked at some qualitative data as well that they'd also collected that they didn't really know how to deal with, because they're statisticians. Doesn't go into R. And actually that was quite valuable as well. And what was valuable was, even though the findings that we had were not statistically significant, they had a lot of meaning for the researchers, the people who work in those courses, particularly when combined with the qualitative data. And I think that's the important thing. They were also able to, as statisticians, they were also able to use the data, although there was no significant differences in certain things. They were able to look at all the associations and do a lot of modeling that way with their data. So they were able to explore factors that were associated rather than significant differences, you know, group A more than group B or whatever. They were able to look at the associations, and that was quite valuable, particularly as part of this exploratory tool. So I would suggest having a look at the types of data that you're collecting, and make sure, actually, because there aren't a lot of student nurses in Glasgow, are there?
No, I think it's around
50 or 60. Yeah. So you're not going to get that statistical power realistically from that. So have a look at data that you can maybe categorize and treat more qualitatively, or even look at purely qualitative data, you know, kind of almost descriptive, you know, written open responses, things like this to certain questions, maybe that kind of evaluative feedback, that might be an element too. But maybe also, you know, look at this kind of categorizable data. Back to that example a couple of slides ago, this one, you know, what is good performance versus what is not good performance? That's categorized data. It's qualitative numerical data. So it can still be modeled statistically. This will result in a chi-squared test, for example, you know, if you're statistically minded. Hopefully, you know, I presume you know a chi-squared test, being a pharmacologist, for example. So that might help. It's a different kind of model of statistics. Yeah, and in terms of where the disadvantages of this study lie, obviously it's a lack of control. Clearly that's the biggest one. You aren't necessarily going to disprove hypotheses here. So the exact nature of any causation maybe can't be determined, but you can explore causal links and associations. And of course, this is one thing that's vital. Any experiment only measures what it's designed to measure. That's always the case. And in a study where you eliminate control, obviously the things that you're not able to measure increase greatly. So the real causal factors become more important to consider and to kind of discuss when you're concluding and discussing your findings. It becomes more important to discuss these potential additional factors here. Since we've got at least two scientists in the room, what's an experiment? What's different with an experiment compared to what we just discussed?
I think you can design it. So I think one of the things that I struggle with and I think that's what you've been getting at, between the scientific approach, where you can say, no, I'm going to have this control group, it's this beaker here that doesn't have this thing added, and then I'm going to have this other beaker over here that does have this thing added, and it's completely within my control, and I don't need to worry about ethical considerations usually, say, in an experiment like that. And you can be very rigid about getting rid of sort of confounding factors. You can home in on the one thing just through your design. Yeah.
So that's the biggest one, actually, is that idea of control. It's whether or not it's in a laboratory, you have that laboratory mindset of everything's controlled. It's not a natural setting, it's a controlled setting, and you can control the variables. Anything else?
I think when you can also find you're looking for specific answers. So, for example, in my study, as you said, I will not be able to answer really what the best method is, whilst I know that paracetamol is good for treating pain. It's better than placebo, and that's a fact. It becomes a fact. Whilst in my case, for example, I will not be proving any fact.
Mm-hmm. So ability to prove or disprove, however you view it, I suppose, that the underlying hypotheses. Again, that comes from, that's strong links with control, doesn't it? But it has strong links with other things as well. You're talking about statistical power, so the amount that you can measure things is controlled, is within your control. You can just keep measuring things and generally expect similar outcomes. So that idea of repeatability is there as well. There's a lot of little things that you can throw into the definition of an experiment and how it maybe differs from that natural setting. You've covered most of them there, really. The other one that maybe you didn't mention, but it's probably sitting in your mind now that we've not mentioned, is the idea of randomization. So your pre-controlled groups are statistically equivalent, or you have already explained the differences in those pre-controlled groups using some analysis. So you've got that idea of randomization, but maybe with certain parameters. You've got that control over who's in what group as well. So that's maybe the only other one. And if you think about all those things that you can do in the lab, a lot of them you can't do with people in the classroom. So, but you can maybe in some instances, like, Raphael, your example is one where you have tried to design an intervention. You've got a group of students and you're treating that whole group of students as both your control and your treatment group. So they are randomized in that sense because they're equal broadly. You are retaining elements of control because you can maybe try and isolate responses to one approach to the other. So there are ways in which you can borrow from your disciplinary beliefs around experimentation and things like this, and actually build that design a bit more ethically as well, and give yourself a bit more kind of structuring it. One thing I did mention earlier on was this idea of positivism, and in relation to that, is an experiment that is perfectly designed actually perfect? And I think that the realistic answer to this is often no, it's not, because whenever you design an experiment, you're working within the theoretical paradigm that you're working in. And so everything's true within that. And therefore, if your experiment fails, the natural conclusion is that the experiment was done incorrectly, rather than something else is explaining this that I've not considered. And that's the idea, again, of this kind of the epistemological position of how do you know what you know, and positivism and things like this. In a laboratory, a couple of weeks ago, I think I mentioned this in my last CPD series session actually, but a couple of weeks ago, there was listening to a podcast about the discovery of X-rays. I forget, it's Röntgen, isn't it? But was it William Röntgen? I can't remember. But the discovery of X-rays was a failed experiment. But it took someone clever to realize that there was value in that failed experiment, and that they shouldn't just go out and redesign this experiment to get it right. They kind of went, what if what I've just seen could be explained by some theory that I've not considered here? So there is that idea of that paradigm and this experimental design being perfect, not always being possible. In a social environment like a classroom, obviously you've got much less ability to control. You've got much less ability to measure variables accurately and to have treatment and control groups. So that idea of experimental design in your classroom for scholarship is even more diluted. It's really almost even less possible, I suppose. It's more, as I say, quasi-experimental. So in a lab setting, for example, you guys will be very used to that. It's highly controlled, very repeatable, very randomized, very perfect, very ideal. In the field, if any of you work in a subject where you conduct your studies outside of that ideal lab in a field setting, it's a much more natural setting as a result. So your control still exists, but it is less controlled. And then in a much more natural setting like a classroom, you've lost your ability to control. So maybe that idea of describing your study as an experiment isn't quite so fair anymore. Still comparative, still get conclusions out of it, still get valuable explorations, but it's not a definitive A implies B by this much outcome anymore. So you're probably not going to lock your students up in a lab, I hope. You might have more chance to do some kind of natural field type experimental, quasi-experimental design. But what's probably more realistic is a much more natural experiment whereby you don't necessarily have that control and ability to isolate variables and factors and things like this. And just being able to discuss that in your studies. So Raphael, you're talking about, should I neglect this? Should I do this in my studies? What's important here is to discuss those findings in light of your lack of control, your inability to isolate things, the lack of statistical power that you maybe have, and so on. You still have valid findings, but you need to situate them in your discussion with appropriate hedging, basically. Couple of simple designs that you could even look at when you're, whether or not they're experimental or post facto, I suppose you can still manipulate your groups a little bit. You might be going down pre-test, post-test route. You're talking about learning gains, Raphael. So learning gains could be from the start of your course to the end of your course. It could be learning gains from the start of your traditional unit to the end of your traditional unit versus the start of your different version to the end of your different version, but you've got some element of pre and post test possibilities within there. You've got matched pairs design, whereby you're looking at, that would be much more statistically significant ideas here, you know, a person in group A and a person in group B resulting in very different outcomes. It's maybe not the best model here to think about, but it is an experimental design that you could have. I suspect you're both quite used to kind of factorial design experiments, you know, looking at putting people into certain groups, categories and things like this. And actually that's maybe more realistic because it is a bit more qualitative in that sense. I mean, you treat the data as categorical data in that sense, so it's much more qualitatively measurable. And that's maybe something to think about. Again, Raphael, your example, that's what we turn to actually as an explanation there. So that could be some kind of design that you could use. And if you're looking up ideas for this, then, you know, looking up a research design textbook, for example, and using these keywords might focus in and home in on a more educational study that fits within this research method, rather than maybe what you're more used to, which is, you know, obviously a pharmaceutical study that fits within this method, and maybe actually linking one to the other is quite difficult to do. So comparative studies in scholarship, absolutely, they have their place. Experimental designs are not necessarily going to be particularly possible ethically or just in terms of socially as well. But the idea of a more natural experiment or a post-facto study is probably more realistic in some cases. So it's maybe worthwhile looking at in terms of your ideas. With that in mind, answered a couple of questions as we went along, but do you guys have any other questions?
I have